Today we will go over reductive amination. Reductive amination uses an amine and a ketone or aldehyde to form a more substituted amine. For example, if a primary amine is used as a reactant, the product will be a secondary amine. The reactant amine must be bonded to at least one hydrogen. This reaction occurs in a few parts. First, amine formation occurs, then a reducing agent is added to form a charged amine which loses its charge through acid workup. The nitrogen acts as a nucleophile and attacks the partially positively charged carbon in the carbonyl. Because the carbon can only have 4 bonds, the oxygen takes an electron pair and becomes negatively charged. The result of this step is a tetrahedral intermediate with a positively charged nitrogen and a negatively charged oxygen. One of the hydrogens bonded to the amine leaves as a proton, resulting in a neutral nitrogen. The negatively charged oxygen takes the proton, becoming a hydroxy group.
The nitrogen uses its lone pair to form a double bond with the carbon, while the OH acts as a leaving group and takes an electron pair. This results in an iminium ion. The negatively charged OH then takes a proton from the nitrogen, neutralizing its charge. Next, we add the reducing agent, which in this case is sodium cyanoborohydride. This releases a hydride, which is a negatively charged hydrogen. The hydride reacts as a nucleophile and attacks the carbon in the imine bond, so the nitrogen takes back its electron pair, breaking the double bond. This reaction is irreversible and results in a negatively charged amine. Protons and water are added as acid workup to neutralize the charge, thus completing the reaction. This step is also irreversible. Please note that this reaction will proceed slightly differently if a secondary amine is used. After the iminium ion is formed, there are no hydrogens attached to the nitrogen to be removed. As a result, the nitrogen will still be positively charged during the hydride attack. Because of this, acid workup will not be necessary to form the final product.